Hi, I'm Zor. Welcome to Unizor Education. Today's lecture is about the third and the last type of curves of the second order called parabola. This lecture is part of the course called Math Plus for all. It's presented on Unizor.com website. Website is totally free for all. If you want to take the course, you don't even have to sign in if you don't want to. You might want to sign in only if you are supervised by somebody else. Then you need just to have this relationship between the supervisor, whether it's a parent or a teacher, and the student. If not, if you're just a self-study, you don't even have to sign in. And there are other courses actually on the same website, on Unizor.com. I started with the course called Math for Teens. Then there is a Physics for Teens. Now this Math for All is partially ready, up to geometry actually. Then there is a Physics for All. There is called Relativity for All. So yes, all of them are free, so you can just enjoy any one of them. Now, what's important is if you found this lecture on, let's say, YouTube or somewhere else, you just found one particular lecture. But any lecture is part of the course, and the course is presented on Unizor.com, where all the items in the course are logically arranged in menus, so you can go, let's say, from website Unizor.com to, let's say, a course called Math for Teens. You can find there the part which is called algebra. Within algebra you can find some other topics of lower order on the menu, and then finally you will get to the lecture. And every lecture, well, obviously lectures are presented in the logical sequence. That's the purpose of the menu. So you have to really go from one item of the menu to another, top to bottom. And also what's important, every lecture has notes. Notes are basically like a textbook, very detailed textbook. With pictures sometimes if it's necessary. So I do recommend to not only watch the lecture itself, but also read the notes. It's just a different maybe view onto the same material. Also, the website has exams. After many topics there are exams which you can take yourself. Usually it's like something like 6 problems with multiple choice. 6 choices per problem, and you can just make sure that you are mastering the material if you have all these problems as part of the exam, and you get the top score, because it will score you. It will give you how many problems you have solved correctly. Okay, back to parabola. So we have to start with definition of the parabola. Now, if you remember, other curves of the second order were defined by their properties. For example, ellipse was defined as the locus of points, all the points on the plane which are which have sum of these two distances equal to some constant. Hyperbola was defined when the difference between these two points, two focuses, two foci, the difference between them is constant. Okay, so how the parabola is defined? Parabola is defined the following way. There is a straight line called Directrix, and a point which is called focus. So the parabola is defined as locus of points, which means all the points on the plane which satisfy the following property: the distance to this directrix and to the point, which is the focus, is the same. So all the points equidistant from a line and a point are belong to parabola, or make up a parabola. Now obviously the first choice, if you put the perpendicular from the focus F to directrix G and have a midpoint, obviously this midpoint equidistant, because the distance from a point to a line is measured by perpendicular. So this is a perpendicular and this is the midpoint, so it's equidistant. Now from here, where is the next point? Well, if you go parallel to directrix, to this point for example, it will not change this distance, but it will increase this. So you should not really go parallel. You should go with a little bit tilt to the right all the time. And similarly here, symmetrical. So that would be the parabola. And the distance from this point to this, and from this point to this is perpendicular, is the same. So that's how you draw a parabola. Okay. So that's number one. Now we have to really come up with some kind of equation in Cartesian and polar coordinates of this parabola. Well, for Cartesian coordinates you have to really have coordinate system, and the best way to do it is basically have this as an x-axis, and if you will do perpendicular to this, or parallel to directrix, through this point, which is called vertex, this midpoint between directrix and focus is called vertex. So that would be origin 0, and that would be y-axis. Okay, in terms of x and y, we can actually draw we can actually have an equation which describes the parabola. Now in this case, for instance, point 0, 0, x0 and y0 belongs to parabola. So we need some kind of an equation, function of x and y. Okay, so how can we do this? Well, basically you have to calculate this distance. Let's say this is p, x, y. Now this, let's call it q. What's the coordinates of the q? Well, we have to really assign some kind of a distance between the point, which is the focus, and the directrix. I would call it 2c, so it will be c here and c here. So coordinates of point q would be x would be minus c, and y would be the same as this one, right, which is y. So pq is equal to what? It's basically, since it's a parallel to x-axis, it's the difference between x and x coordinate of p and x coordinate of q, which is p has coordinates, this is x, so this is x, this is c, so it's x plus c. Now pf, oops, pf, okay, what's the coordinates of f? C will be coordinates along the x-axis. This x coordinate would be c, and y coordinate would be 0 because it's on the 0. Okay, so I have coordinates of p and coordinates of f, and now all I have to do is just square root of difference of each coordinate squared, right? So it's square root of x minus c squared plus y minus 0 square, which is y square. And they are supposed to be equal to each other, right? Here is an equation. Well, the easiest way, obviously, since they are equal, we can just square both sides. So it would be x plus c square is equal to whatever is under square root. I will put this one to the left, so it will be minus x minus c square equals y equals y square. Now, if you will open the parentheses, what do we have? X square plus 2xc plus c square minus x square. Minus and minus will be plus 2xc minus c square equals y square. And guess what? This goes, and what we have is y square is equal to 4xc, or rather for cx, I'd rather put for cx. This is the equation of this particular parabola. Now, let me just make a point that this is not an equation of a function in a kind of a traditional sense, because the function, traditionally function is, whenever you have the value of x, you can derive using the function, whatever the formula is, one and only value for y. In this case, we derive two actual values of y, plus and minus. This is the symmetry. So it's not, this is not the way how traditionally it's called. And by the way, the parabola which you used to have, something like y is equal to x squared, which is basically the same thing as this one, but turned 90 degrees. Well, it just means that x is y and y is x. That's what a rotation by 90 degree actually is. So you change you change the rows. In this case, this is a traditional function, because for every x we have only one y. In this case, for x we have two y's. But that's not really very important right now. What's important is that this equation describes the curve, describes the set of all points on a plane which satisfy this particular condition, that the same equidistant from a point, from a focus, and from the directrix. So that's what's important about this formula. So let's not call this description of a function, because the function is usually something else when you have one particular value of y for each x, where x and y are not really in the same row. X is argument and y is function. In this case, x and y are basically two coordinates, and they are combined into whatever the formula is to describe the set of points on a plane which satisfies certain conditions. So the condition is equidistant, and this is the formula which describes locus of points which satisfy this condition. Okay, so basically we have finished with this particular task of having a formula which describes in Cartesian coordinates our parabola. Now, the terminology-wise, so we have what? We have vertex, we have focus, we have directrix. Also, sometimes there is another characteristic which is called AB. If you will, from the focus, have a line parallel to directrix, it intersects in 2 points. So AB is called width of the parabola. This is the distance between points which you obtain by cutting parabola at the focus by the line parallel to directrix. So what's the distance? Well, let's have the coordinates of point A. We have a formula right now. X is equal to c, so y square is equal to 4c squared, right? So y is equal to square root of this, which is 2c. No, but y is only from focus to A. Now the whole AB is twice as big, which is 4c, which happen to be the same as a multiplier here, but that's just a coincidence. Okay. Now, the last thing which I wanted to do is to do it in polar coordinates. Okay, so let's wipe out this. And it's a very easy actually exercise, even easier than in Cartesian coordinates. Okay. So let's start from Directrix and the focus. Now this is how our parabola will go. And I would like to use polar coordinates with a center at focus. That's what's important. Now this used to be an x-axis, right? That would be our base axis from which we will measure the angle theta, and the distance to point P r theta would be r, right? And this is also r, supposed to be, right? That's where we will do the equation. So we know the distance to focus, which is r. Now what's the distance to Directrix? Well, this is C, and this is, let's call this point Q. What is FQ? FQ is equal to R times cosine of angle, right? R cosine of theta. Now FQ and C would be this length. So R is equal to this one, right? So R is equal to 2C plus FQ, which is R cosine theta, from which R is equal to 2C divided by 1 minus cosine theta. Am I right? This goes to this, 1R outside, 2C divided, yes. And this is our formula for parabola in polar coordinates. Now, I would like actually to discuss just a couple of words about this formula. Maybe you remember, maybe you don't, but if you remember the formula for ellipse and hyperbola, they did look alike actually. There are different things in the numerator, but in the denominator it was 1 minus eccentricity, E times cosine. Eccentricity for ellipse was less than 1, for hyperbola was greater than 1, and for parabola, as you see, this coefficient at cosine, which is used to be eccentricity, which is equal to 1. So eccentricity of this curve of the second order actually defines the shape. If it's less than 1, it's ellipse. If it's equal to 1, it's parabola, and if it's greater than 1, it's hyperbola. So just a side note, and we will use it when we will talk about in the course of physics for all, physics plus I think it's called, when we will talk about gravitational field and trajectory of some object which comes into the gravitational field of planet or whatever. It will always be some kind of a curve of a second order. It might be ellipse if it's relatively close to the planet. It might be hyperbola or maybe parabola. I mean, all depends on initial conditions, where exactly the object located at time 0 and what's the velocity relative to the body which gravitates, which makes up this gravitational field. So all these would be very handy when you will use the polar coordinates. It would be much easier than in Cartesian coordinates. Just a side note. But that will be in the physics. Okay. So that's it for today. I suggest you to read the notes for this lecture. Again, you go to unizor.com, choose the course Math Plus for all, and in the part which is geometry, you can find the lecture for parabola, as well as ellipse and hyperbola, their optical qualities, asymptotes for hyperbola. By the way, parabola also has optical qualities, and we will talk about this in the next lecture. Okay, that's it. Thanks very much, and good luck.